Hey everyone, so now I will continue, that is chapter 14. So here I will talk about the logical statement. So logical statement, especially I will talk about the if logical statement. So what it says is that if you have a logical test and then if it is true, it gives you the statement you want. If it is false, it gives you the statement you want. And let me just give you one example before continuing our wind power example. Say that I have a number here, I have another number here, and then I'm saying that if this number is less than that number, which is of course less, and tell me that it is correct. Otherwise, tell me it is wrong. I'm giving in quotations because it's not a number, it's a string, and therefore I'm using quotation. So you see it is correct. If I just put it as 15, it just gives it is wrong. Or you can go this way and you can say that if this value is less than that value, just multiply them. Otherwise, bring me the value of 0. So you can see it brings the 0. If I put that here as 9, it just multiplies, and this one also updates. So this is how if statement works. So I will apply the if statement to our problem and then see how we can apply in a real world problem. So in the wind turbine case, I have the minimum speed. Minimum speed is the cut-in speed also called. So wind turbine will not operate, if till it reaches this speed. So if it is at, for example, 2.93, it will not operate, but when it reaches 3 point something, it starts to operate. That's the minimum speed for the wind turbine to run. And the rated speed is that whenever we reach that speed, the wind turbine starts to give us the constant power. So it is the power that is maximum power that you can get from this wind turbine. That is also called the optimum power. Okay, and for this problem, rated speed is at a 10.98. So, and then we have the cutoff speed, and cutoff speed is that, as the name says, the wind turbine gearbox breaks, and then it doesn't rotate because we are trying to be on the safe side. Otherwise, the blades can break. So these are as you can see, it looks like an if statement. So I will need to put an if statement saying that if the speed is lower than this one, do not run the wind turbine. If it is higher than this one, do not run it. If it is in this range, make it as a constant power. So let's do that here. I will insert a column and say that let's call it real wind power, again in watts. So I will say that if the wind speed is less than the cut-in speed, which is this value, you can put a number by yourself, okay, or you can put the value here. So I will just put this value here. If the wind speed is less than this value, give me 0. Don't give me real wind power. Otherwise, if it is false, then give me the wind power. Wind turbine power. So if it is less than this one, give it 0. Otherwise, give the wind turbine power. Okay, and then when I double click here, so it will not give true values because I did not say that this cut-in speed is a. So I will put a $sign. So I'm saying that I'm always comparing with the same speed. Otherwise, it will shift on. So then let's run it. You see, till that speed, it doesn't run. It gives me a 0. After that speed, it starts to run. And next comes cutoff speed and the rated speed. Let me start with the rated speed. And for this one, I will say that if the speed of the wind is less than this one, let me just erase the statement here and put new one so that you are not confused. I'm saying that if the wind turbine speed, this one, is greater than or equal to that one, If it is greater than or equal to that one, give me this speed. I mean this power, sorry, this power. Otherwise, no need here for else case, because we have the here no need to give an else case. Let's put it as this one as else case as, let's say that, error, because it should not be the other way around, then we have a problem. Okay, so let me run it for the all cases. As you can see, let me see, go back here, sorry, so D13, it should be again a dollar, you know, it is always this value. Okay, let me just run one more time. So you see, since always the wind speeds are higher than or equal to this value, it will always give me this constant speed, which is the speed at here. Let me just mark it, and you can see it is the same. Now I'm coming to cutoff speed. In the cutoff speed, I would say that if the n values are greater than this value, just bring me the zero value. So let me just run if statement again. I'm saying that if the wind speed is higher than this cutoff speed, and then bring me the zero value. Otherwise, then again, let's say it is again error. Error means that there is a problem with your data, because it should be the other way around. So let's run it and see if it works. Again, let me just put $sign here, because it's absolute reference. They call it as absolute reference. Let me see. And this one shows error, because so you can see this one is a, I mean, it should be greater than equal to, let me see, yes, because at this speed it also stops. It stops at this speed, and as well as the speeds greater than this one. This is the cutoff speed. So now our data looks like good now. Okay, let's now plot it again. So I will just use my previous plot window, and then let me right click and then select data, and then add one more, call it as real wind turbine power, and the x values will be the same x values that I have here. Okay, and then y values will be the real wind turbine power. Again, I will make it as a secondary axis, but let me just firstly finish this one and tell it okay. And then, okay, our data appeared. Now right click, format it, and secondary axis, which is good. But the problem is now, let me just see. Sorry. The problem is these data are, this is very small data, you can see. So you cannot clearly see what's going on here. So what you can do is that you can again right click on it and then select data, and then make wind turbine power and the wind speed statistics as invisible. And then let me move it down a little bit to the left. Okay, so now you can see, so we have a region 1 where wind speed doesn't work. Let me just note it here. So we have a region 1, wind turbine does not run. So we have a region 2, which is this part, and the wind turbine, let's say startup. And then we have a region 3, we have the wind turbine, but it runs at constant speed. And then we have the region, last region, where wind turbine, you see that it shuts off and stops rotating. Okay, so this is how you use the if statement in your case. And also you can add the line for this one. Okay, you can format data series, and then you can add a line here. Say that you have a solid line, you can see that the solid line. And also you can play with the marker, and then you can make your built-in markers as maybe triangular case, and the size you can increase. You can change the color to red so that it looks fine. Okay, this is the real wind turbine. Let me just put it somewhere that we can see what's going on here, and you can add your other data. Let's see. Yes, it's very small value so that it doesn't show up here well. But this is the real wind turbine, but this is the, I mean, theory, but this is the wind speed statistics.